Have you ever just looked up at the night sky and felt, well, a little lost? I mean, it's this brilliant, beautiful chaos up there. For thousands of years, that's pretty much all it was. But today, we're going to uncover the incredible story of how we took that cosmic mess and actually drew a map, turning all those countless points of light into a guide we can still use. So let's dive in.
Right, so this is the big question, isn't it? From ancient shepherds all the way to modern astronomers, we humans have always felt this deep need to not just, wonder at the stars, but to understand them, to chart them, to use them as our guide. So how on earth did we do it?
Okay, first things first, let's start with the basics. What are we even looking at up there? Before you can map anything, you have to get a sense of the scale of the challenge. And for our ancestors, all they had were their own two eyes.
On a really, really good night, far away from any city lights, the human eye can pick out about 2,500 stars. That sounds like a lot, right? But get this, it is just the tiniest sliver of the more than 100 billion stars in our Milky Way galaxy alone. What we're seeing is basically just our immediate cosmic neighborhood.
And this right here, shows you just how big that challenge was. I mean, think about it. The greatest star catalog of the ancient world, the Ptolemy's Almagest, had just over 1,000 stars. Centuries later, Johannes Hevelius, who was the last great astronomer to map the sky just by eye, he only got up to about 1,500. It just goes to show you the absolute limit of what was humanly possible before the telescope came along and changed literally everything.
So when you're faced with thousands of random points of light, what do? Well, you do what we humans always do when we're faced with chaos. We look for patterns. We started connecting the dots, creating familiar shapes and telling stories about them. And that was the very first step in making a map of the sky.
And that brings us to a really crucial point about the word constellation. See, back in the day, it just meant the picture, the shape, like Orion the Hunter or Ursa Major, the Great Bear. But for an astronomer today, a constellation isn't a picture. It's a precisely defined patch of the sky. Think of it like a country on a world map. Everything inside those borders, every star, every galaxy, belongs to that one constellation.
Okay, so if a constellation is a country, what's an asterism? Well, just think of it as a famous landmark inside that country. It's a really simple, super recognizable pattern of stars that isn't an official constellation all by itself. And the most famous example of all? The Big Dipper. That's an asterism. It's just one part of the much, much larger official constellation, Ursa Major.
So how did we make that jump? How did we go from seeing constellations as just, pictures in the sky to defining them as these official territories with borders? This shift was a huge deal. It was the moment the skies stopped being just a storybook and started becoming a true, honest-to-goodness scientific map.
This quote right here really nails the problem they were facing. Before we drew official borders, the sky was, it was a mess. You had some stars that belonged to two different constellations at the same time, and then whole empty patches that didn't belong to any constellation at all. It was total cartographic chaos.
So, in the 20th century, astronomers finally decided, okay, it's time to clean this map up. In 1922, the brand new International Astronomical Union, the IAU, they agreed on a final list of 88 official constellations. Then, over the next decade or so, they painstakingly drew borders along the sky's natural grid lines, what we call right ascension and declination. And by 1935, it was done. Every single point in the entire sky officially belonged to one and only one constellation. The map was finally complete.
And here's a really fun little bit of trivia that came out of drawing those precise borders. Because of where the lines ended up, the sun's path through the sky, the ecliptic, it actually passes through a 13th constellation, Ophiuchus, the serpent bearer. But since it's not one of the original 12 from ancient astrology, it gets called the forgotten sign of the zodiac. Pretty cool, huh? All right, so now we have our official territories, but we need a way to actually display them, right? This brings us to the absolutely beautiful and scientifically crucial world of the celestial atlas. These are the true roadmaps of the cosmos.
At its heart, a star map really only has two jobs. It's pretty simple. First, it helps you figure out what that bright thing you're looking at is. And second, it helps you find something you're looking for by using its coordinates. It's probably the most fundamental tool an astronomer has. But listen up, because here is the single most important and, often confusing tip for using one. On a star map, east and west are flipped. I know it sounds weird, but the logic is actually simple. You're not looking down at a map of the Earth, you're looking up at a map of the sky. So if you hold it over your head, you'll see that east on the map is now on your left, and it perfectly matches the real sky above you.
And man, these maps have such a rich history. They started out as these beautiful artistic works, like all Sufis in the 10th century. Then they became the first modern atlases, like Bayer's Uranometria in 1603. And that journey took us all the way to the incredible photographic atlases of the 20th century, which could capture millions of stars way too faint for any human eye to ever see.
So let's zoom in on one of the most important and, frankly, most beautiful star atlases ever made, Johannes Hevelius's Uranographia. This thing represents the absolute peak of what was possible with pre-telescopic, hand-drawn star mapping. It's just a work of art.
I mean, this atlas from 1690 was just a monumental achievement. We're talking 56 stunning maps charting over 1,500 stars. And the accuracy? Just 1 arc minute. To give you some perspective, there are 60 arc minutes in 1 single degree of sky. It was the absolute limit of what you could do with the naked eye and a steady hand. And that level of precision still holds up today. His artwork was so good, it basically became the classic way we all picture the constellations.
Okay, we've covered a lot of ground here. We've gone from just staring up at the sky to the super intricate details of star atlases. So what do you say? Let's put that new knowledge to the test with a couple of quick questions. Ready? First question. You see that famous W shape up in the northern sky? Is that an asterism or is it a constellation? The answer is, it's kind of a trick question. It's both. The W itself is a super famous asterism, and it forms the brightest part of the official constellation, Cassiopeia. It is the perfect example of that landmark within a country idea.
And for our second question, you're holding a star map. You want to find a star that's to the east of your target. Do you look to the map's left or its right? Remember the golden rule. Because you're looking up, the map is reversed. So east is always on the left.
So, let's just quickly bring it all together. What are the big takeaways here? First, the entire sky is neatly divided into 88 official territories called constellations. Second, those famous patterns we all know, like the Big Dipper, they're usually smaller asterisms hiding inside those bigger constellations. And finally, the maps we use are incredible tools, just as long as you remember that one weird golden rule. East is left.
When you think about it, we've come a long way, from just gazing at a few thousand stars to mapping our cosmic neighborhood with incredible precision. This whole story has been about turning the unknown into the known, which leaves us with one last thought. Now that our own sky is so thoroughly charted, what are the next great unknown maps that are still out there, waiting for us to create?